Hi, welcome to today's classes. Dear children, today we can discuss about three-dimensional geometry. In vector concept, we study direction ratios of a vector, direction cosines of a vector, how they are related. So we have to recall those points once again. Let us see. If vector AB makes angle alpha, beta, gamma with x-axis, y-axis, z-axis, then cos alpha, cos beta, cos gamma are known as direction cosines. What about direction cosines of BA vector? AB vector, just opposite is BA vector. What will be direction cosines of that vector? We know alpha, beta, gamma are the angles made by AB vector. Then BA will make pi minus alpha. So direction cosines are cos pi minus alpha, cos pi minus beta, cos pi minus gamma. We know cos pi minus theta is minus cos theta. So minus cos alpha minus cos beta minus cos gamma are the direction cosines of vector BA. What are direction cosines of x-axis? X-axis direction cosines 1, 0, 0. What about minus x-axis? Minus x-axis minus 1, 0, 0. Y-axis direction ratios 0, 1, 0. Similarly, minus y-axis 0, minus 1, 0. What about z-axis direction cosines 0, 0, plus 1. Negative z-axis it is 0, 0, minus 1. These are direction cosines of x-axis, y-axis, z-axis. Let us discuss a small question. A vector is making an angle alpha, that is 90 degree, beta with y-axis 135 degree, with z-axis gamma 45 degree. What are the direction cosines of this vector? DCs. We know it is cos alpha, cos 90, which is 0. Next, cos beta, that is cos 135 degree. Cos 135 is cos 180 minus 45, which is minus cos 45 equals minus 1 by root 2. Cos gamma. Cos gamma is cos 45, which is equal to 1 by root 2. So direction cosines of this vector are 0, minus 1 by root, 1 by root. What will be direction cosines of BA vector? Cos 90, cos 45, cos 135 will be direction cosines of BA vector as per the previous theory what we discussed. Next, what will be equation of a straight line passing through a given point? Say A is a point x1, y1, z1, parallel vector, vector B, which is represented by AI plus BJ plus CK. All of us know the straight line diagram. It is like this. Passing point is ready. P point is ready. That is parallel vector is also ready. B. So A is x1, y1, z1. P, the passing point is x, y, z. This is vector R. This is vector A. Now, guys, the equation of the straight line, Cartesian form and vector form. Vector form is vector R equal to A plus lambda, which is a constant, into B. What is Cartesian equation? x minus x1 by A, y minus y1 by B equals z minus z1 by C are the direction ratios of the line is A comma B comma C. What is direction cosines of the line? Direction ratios are ready. That is ABC, no doubt. What about direction cosines? DRs of the line. DRs of the line is very clear. A comma B comma C are the direction ratios. What about DCs of the line? Here children, DCs means direction ratio divided by magnitude. That will be A by root of A square plus B square plus C square, comma B by root of A square plus B square plus C square, and C divided by root of A square plus B square plus C square. These are direction cosines of this line. Now, let us consider one coordinate, say A 3 minus 1 2. Passing vector B is 2i plus 5j minus 6k. How can we write vector equation? Vector r is equal to a plus lambda b. From where will we get a? Vector a is from passing point A. Here passing point is ready. So vector a will be 3i minus j plus 2k. Vector b already available. So we can write the answer 3i cap minus j cap plus 2k cap plus lambda b vector 2i plus 5j minus 6k. If this equation is available, what are the direction ratios of this line? After lambda, b vector will come. B vector ratios are 2, 5, minus 6. That itself is direction ratios of this line. What about Cartesian equation of the line? X minus x1, that is our formula. X1 is x coordinate of the passing point, that is 3. X minus 3 by A. A is getting from the parallel vector. Parallel vector A is 2, B is 5, C is minus 6. So x minus 3 by A value, that is 2. Y minus y1. Y1 is minus 1. So minus minus become plus 1. Divided by B, 5. Z minus Z1, where Z1 is 2, divided by C is minus 6. This will be Cartesian equation of the line. So, derivation is important. Vector form, Cartesian form. Once a coordinate and vector is given, how to find the equation? These are important things from the straight line concept. Now, children, how can we find equation of a line passing through the origin and parallel to x-axis? Equation of a line passing through origin. So, passing through origin means passing coordinate is ready. 0, 0, 0. That is x1 is 0, y1 is 0, z1 is 0. And parallel to x-axis. You know, x-axis direction cosines are 1, 0, 0. Even direction ratio is 1, 0, 0. So the equation is x minus x1. x1 is passing coordinate, y1 is 0, z1 is 0. A value, since it is parallel to x-axis, A is 1, B is 0 and C is 0. So x minus x1 divided by A equal y minus y1 divided by B equal z minus z1 divided by C. This is the equation. Sorry, x minus x1. x1 is 0. X minus 0 divided by 1 equal y minus 0 by 0 equal z minus 0 by 0 is the equation of straight line passing through the origin parallel to x-axis. If it is parallel to y-axis, instead of 1, 0, 0, you can write 0, 1, 0. Parallel to z-axis, same numerator, and denominator will be 0. Here it is again 0, and here it will be 1. How to find angle between two lines? When there are two lines, one is vector r equal to a1 plus lambda b1. Next line, r equal a2 plus mu b2 are the two intersecting lines. Then angle between them, say theta. The formula is cos theta equal modulus. Modulus means acute angle we are calculating. b1 vector dot b2 vector by modulus of b1 into modulus of b2. Since b1 and b2 we can write in components a1, a2, b1, b2, c1, c2. The formula can be reduced a1, a2 plus b1, b2 plus c1, c2 divided by root of magnitude of b1 vector is a1 square plus b1 square plus c1 square. b2 vector magnitude is a2 square plus b2 square plus c2 square. This is the method of finding angle between two lines. Special case, lines are parallel. Lines are parallel, then b1 vector, b2 vector must be parallel. b1 is parallel to b2, or else the ratio of a1 and a2, b1 and b2, c1 and c2 are equal. Condition for lines to become parallel. Lines are perpendicular. Lines are perpendicular means b1 dot b2 must be 0, or cos theta becomes 0 when theta is 90 degree or perpendicular condition. Such cases, the numerator part a1 a2 plus b1 b2 plus c1 c2 must be 0. So this is the condition for perpendicularity of two lines. This is the condition for parallel condition of two lines. Now, let us discuss one question to find value of angle as well as unknown quantity k. Let us see a textbook question. The question is, if the lines x minus 1 by minus 3 equal y minus 2 by 2k equals z minus 3 by 2, and the next line is x minus 1 by 3k equal y minus 1 by 1 equal z minus 6 by minus 5 are perpendicular, find k value. How to find the k value? First, you see whether the equation is in standard form. How to find the equations are in standard? First point, all the equations should start with the variable x, y, z. Starting is x, okay, y, okay, z, okay. That part is okay. Then minus sign, okay, minus sign, minus sign, minus sign. Coefficient of x, y, z must be 1. So here it is 1. Nothing is written means 1, 1, 1, 1. So pakka equation is in standard form. If it is in standard form, catch the denominator terms. This will be a1, this is b1, c1, a2, b2, c2. So we have to consider a1, a2. That is what we wrote in the previous case. Plus b1, b2 plus c1, c2 must be 0 when lines are perpendicular. And what is a1? The first term is a1. This is b1. This is c1. So a1 is minus 3. a2 is 3k. So we have to multiply these two numbers. Minus 3 into 3k plus next 2k and 1. that is B1 and B2. 2k into 1 plus C1, C2, 2 and minus 5 equate with 0, minus 9k plus 2k minus 7k, minus 10 goes to right side, become plus 10. So k value is 10 divided by minus 7 or minus of 10 by 7 is the value of k. Like this they can ask, show that the lines are perpendicular. Then the same method, multiply those numbers like the same order. If the answer is getting 0, then those two lines are perpendicular only. Let us see another question. What is there in the textbook? That question is, find angle between the lines whose direction ratios are given A, B, C, and next direction ratios B minus C, C minus A minus B. These are direction ratios. Whenever direction ratios are given, we can find the angle between them. That is what the relation we are writing. We have cos theta is equal to A1, A2 acute angle plus B1, B2 plus C1, C2 divided by magnitude of the first vector into magnitude of the second vector. These A1, A2, B1, B2, C1, C2 are nothing but direction ratios only. So you can take this as A1, this as B1, this as C1, this is A2, this is B2, and this is C2. Shall we multiply them and check? Equal to A into B minus C, A into B minus C plus B into C minus A, C minus A plus C into A minus B. Let us see what happens. Denominator part we can leave as such. Okay, let us see what is the numerator. When I multiply A into B, AB minus AC plus BC minus BA plus CA minus CB. AB, BA cancelled, AC, CA cancelled, everything is cancelled, answer become 0. 0 divided by any magnitude, non-zero magnitude will be 0 only. So cos theta 0 means theta is 90 degree. That means the lines with these direction ratios are mutually perpendicular. That is the reason why the numerator part, direction ratios product is becoming 0. So these type of questions are really important. Now children, how to find direction, cosines and theta? If you take the ratio of each quantity here, that will be direction cosine only, or cos theta can be represented L1 L2 plus M1 M2 plus N1 N2. This is a result for finding angle between the lines when direction cosines are given. Direction cosines are given, you can calculate. Let me discuss a numerical. The direction cosines of a line are 1 by root 2, comma 0, comma 1 by root 2, say minus. This is of first line. This is of second line. I can write 1 by root 3, comma minus 1 by root 3, comma 1 by root 3. So given is direction cosines. How to find angle between the lines? Simple. That is what I taught. Cos theta formula, direction cosines. Use the formula. Substitute L1. This is your L1. This is your M1. This is your N1. L2, M2, N2. Multiply 1 by root 2 into 1 by root 3 plus 0 into minus 1 by root 3 plus minus 1 by root 2 into 1 by root 3. That is 1 by root 6, 0 into anything becomes 0, minus 1 by root 6. Again cancelled 0. Since cos theta is 0, again we can identify theta is 90 degree. So when the direction ratios are given, we can calculate angle. Direction cosines are given, then also we can calculate the angle. Now, next, what is meant by skew lines? Lines are said to be skew lines if they never intersect. If they are not lying on a plane, that means they are non-coplanar. So, non-coplanar, non-intersecting lines are known as skew lines. What is the expression for? Shortest distance between skew lines. The shortest distance between skew lines. Let us see two skew lines. One is R equal A1 plus lambda B1 and R equal A2 plus mu B2. These are two skew lines. Then this distance, the distance which is mutually perpendicular to the lines L1 and L2. The shortest distance formula is D equal modulus A2 vector minus A1 dot B1 cross B2 divided by modulus of B1 cross B2. If the shortest distance is 0, that means lines are intersecting. Intersecting lines are always coplanar lines. So if the question, any hot question they ask, verify whether the lines are coplanar or not. What you can do is, you calculate A2 minus A1 dot B1 cross B2. If that part is becoming 0, then the lines are intersecting. If the lines are intersecting, they are always coplanar. If the lines are skew lines, then this numerator part will not be 0. Then you can calculate a value that will be the required shortest distance. What about when the lines are parallel? See, the distance between two parallel lines. Parallel lines R is equal to A1 plus lambda B. R equal A2 plus mu B. So this is distance between parallel lines. Distance between parallel lines. This is the distance, that D. So D has a formula that is again same A2 minus A1. A2 minus A1. Here it is cross B vector divided by modulus of B vector. This is the formula for finding the distance between two parallel lines. So line equation is given. How to identify lines are parallel? After the lambda and mu, the same vector will be present. Same vector is present means they are parallel lines, or they are B vector remain same. Okay. In this case, B1 and B2 will be different vectors. Then you can find shortest distance. They are skew lines. Okay. Let us see another concept based on this.